So question 15, 16, and 17 get to this whole other idea of like changing a function or adjusting a function to fix any discontinuities we might want to fix. And they call that an extended function. It's when the mathematician's like, oh, this is pretty close to continuous, but it's not quite. I can almost fix it. Let me like redefine the function or extend rules on the function so that I plug up holes. Basically, we're trying to fix discontinuities. We can only fix them if it's a hole in the graph. We can't fix it if it's a break. Because to fix a break, you have to actually like move a whole part of the function. But you can always just plug up a hole by changing the y value of the function at that point. So when they ask us about question 15 and what value should be assigned to f of 2 to make the extended function continuous at x equals 2, I just noticed that at x equals 2, if the y value at that point happened to be 0, then that hole would get filled in. And we would no longer have a problem. If it's a hole in the graph, the limit exists, and that's considered removable. And I can remove it by saying, hey, let's pretend that x equals 2 produces a y value of 0. End of story, and we'll just extend the function. We'll fix it. And with 16, it's the same idea. What new value should we assign to f of 1 to make the new function continuous at 1? So I would have to like go in and change this rule so that this hole, this little dot, actually fills in that hole. So instead of having, when x equal 1, having a y value of 1, I would change it to be a y value of 2. These are kind of weird questions because you're like, wait, well, how can I just change a function? And really, like, it's not something we normally do after this section. It's just trying to emphasize the idea that we have removable and non-removable discontinuities. So some discontinuities are really bad, like the one at 0. That's a pretty serious discontinuity. I can't fix that without changing everything about this side of the function or everything about this side of the function. We don't want to do that. That's like, you can't remove that without making major changes. It's non-removable. And the limit at 0 doesn't exist. That's why it's a break. Because if I approach 0 from the right and I approach 0 from the left, I end up in different places. But these ones up here, the one at 1, the one at 2, those are removable because the limit exists. So we're just trying to get that whole idea of limit existing, meaning both sides go to the same place. The function's practically continuous. You just got to fill in that hole. That's what's happening. So with 16, yeah, just make x1 equal 2. And then for 17, the answer is no, because it's a whole freaking break. The limit doesn't even exist. You have to make major changes to the function to get it to line up. We can't. We're not going to go crazy. Right? I mean, nuts.